Welcome everyone. This is Arulpiragasam Anpuchselvam, medical student, University of Colombo, Sri Lanka. There are 2 or 3 or multiple vectors, so we have to identify the resultant of all these vectors. We will start from a simple 2 vector question. Okay, there is a vector towards north A, and there is another one B to east. So I have to find out the resultant of these 2 vectors. So for the explanation purposes, I am taking these 2 as force. Okay, let me consider this object. There is an object. This A, force A is in this direction and force B in this direction. So everyone know by this common sense the resultant force will be in between these 2 vectors, these 2 forces. If these A and B are equal forces, this object will move in the middle, 45 degree, 45 degree. If A is greater than B, this resultant will come near this A vector. If B is greater, this resultant will come near the B. We know this from our practical life. So how can we find out the resultant in a methodical way, proper way? So I have to draw the first vector A, okay, the direction and proportional length. Then I have to follow from the end of vector A, I have to start the vector B according to the length and direction, vector B. So from this start of A to the end of B, this will give the C vector, means the resultant of A and B, both vectors. So we already know if A and B 2 forces are, if we apply these 2 forces in an object, the resultant will be between these 2. So this is the methodical way. Look, this is the length of the resultant. We can measure this length if it is 5 centimeter, as we took initially 1 centimeter to 1 Newton. So we can find out this resultant will be 5 newtons in this direction. So we have find out the value, magnitude, as well as direction also from this method. Okay students, this is not only for 2 vectors. As I mentioned before, we can do this method to multiple vectors. Okay, B, if there is any C, D, E, whatever, so I can draw this C, D, E, okay, whatever, we can continuously draw all the vectors. Finally, what is the resultant? Where we started, first vector, where is the finishing point of the last vector. So this will give the resultant of all these vectors. This will be the resultant. So this will represent the length. Length of this line will represent the magnitude, and the direction, this angle, we can say how many theta from north. Okay, change. What is the change in a vector? Okay, for this change I am taking velocity. Okay, there is a vi means initial velocity. This is initial velocity of a motorbike or some particle. Okay, this is the vf final velocity. This is, these two are velocity means it contains the direction as well as magnitude, so it's a vector quantity. So first this was the initial velocity, and then it changed into the final velocity in this direction and in this magnitude. So we have to find out the change. Usually we are notating the change by delta, so delta v we have to find out. So there is also a proper way to find out the change. So as we did before also, we have to draw the first vector vi, initial velocity. Initially we draw continuously, then vf here, but for the change we can't do like that. From the starting point we have to draw this vf. It should be parallel, this direction and length should be, we have to both are same. Okay, from this end of the initial to the end of the final, this will give the change delta v. This length of this line will give the magnitude and this will be the direction. So how can we understand this? As we resultant, we understand by the resultant force, what is the direction the object is moving, so we can we understood how this resultant concept is working. Now how can we understand this from the resultant concept of the vector? Initially there was a velocity vi in this direction north, then it changed to the, finally it changed to this direction, this magnitude. How can I change this into this? First of all, I have to give equal and opposite vector minus vi. If I give minus vi, these two vectors will be cancel each other. Then what can I do? I have to add vf vector. Yes, now these two are cancelling each other, so this vf will be the final velocity, final vector. So what I have did for this system, initially this vi towards the north, what I have made minus vf or vf in this direction, vi in this direction, opposite direction, and vf in this direction. So I have to find out the resultant of these two vectors, because these two are the change we did in this system. So I am drawing this same length and opposite direction. I am starting from this point vi minus, okay, vi minus vi. First we applied this to cancel this vector, then we applied vf. So from this start to this end, this will be the resultant of these two. As I mentioned, we already find out this is the direction, so these two are parallel. We can understand what we have did to this system to change vi to vf. So this resultant will be the delta v, both are same. So we can understand this. So if we understand this, we can easily find the answer in MCQ question. Finally, I want to give you an important tip. it will be helpful in our mechanics, in the projectile motion or anywhere. It will be helpful. There's a vector called vector A in this direction, and it is making theta angle with the horizontal line. If we consider I am throwing a ball in velocity A with the angle of theta, I can divide this vector. This is a velocity vector quantity, so I can divide into two directions perpendicularly. One vector will be in this direction and this direction. Now you can understand, before this we did resultant of two vectors. Sum of these two will be this. Now we are dividing this into two parts. Both are, if you understand this concept, both are same. So how can I replace this vector A? If I cancel this vector, how can I replace the same vector A in two directions perpendicularly? Okay, first let me tell about the mathematics, basic trigonometry. This is a 90 degrees, so it is a right angle triangle. So hypotenuse, this, if I consider this theta, this will be opposite side, this will be adjacent side. So how can I relate adjacent and hypotenuse in this triangle? What will be the trigonometric relationship? Yes, absolutely. It's, if I write cos theta adjacent A divided by H. If I take this A, H cos theta. H means, sorry, I should replace small a cos theta. This will be this vector. So in this horizontal direction, I can divide this vector A cos theta. If I consider this, because these both are parallel and equal in a rectangle, so I can, if I find out this side, this will be equal to this side. So this is opposite and hypotenuse. So the relationship will be sin theta opposite divided by A, this. So if I find out the O, opposite side, A sin theta. If this is A sin theta, this is also A sin theta. This is the proper way of doing this mathematically for our MCQs and for our general. We should save our time during our MCQs, so we can understand this as, if I consider this V vector in this direction, and this is the angle theta, so I can divide into two perpendicular directions. So if I divide with the angle theta, it means adjacent side with the theta angle. So I can tell cos theta V cos theta. If it is opposite to this angle, this will be opposite, means V sin theta. So I have erased this V vector and put this into two vectors. So again, if we find out the resultant to these two, that will give the V vector as the resultant. So we are doing in both directions a question. Thank you very much.